Hi everyone, so we're just going to have a little look at this compound angle formula, or this formula, whatever you want to call it. We'll just hide this wee thing away. So, a lot of this stuff here, right, there's lots of words going on here, but what we're doing here is we're adding two sinusoidal waves, cosine and sine waves, and if you add two waves together, they will produce one resultant waves, and you can describe them either as a sine or a cosine, even though they are related to each other. So there you go. Sine x, well, base x starts at origin, finishes at 360 or 2 pi over the radians. Okay. Cosine, it starts above the origin as its maximum amplitude, and finishes its maximum amplitude over 360 or 2 pi. If we add them together, we actually come up with this other wave here. That's what happens. Just mixing the two together. So we end up with this thing here. So R, the resultant amplitude, positive to negative. That's it. And it's out a little bit alpha. So it doesn't quite start over where cosine would start or where sine would start. So I'm just referring to this as in terms of sine. Could be cosine. That's fine. So in terms of compound angle formula, we've got 4 versions of it here. So just take your time to absorb these. And I know students will say, oh, do we get this in an assessment? Yes, you do. But it wouldn't take you too much time to have a wee look at these and memorise these. Why don't you try it? So let's go for the first one. We're going to take two waves form. Here's 3 cos x, 4 sin x. Let's express it in the form r sin x plus alpha. So r is going to be a resultant amplitude. It's going to be in some way a combination of 3 and 4. I'm not going to quite add them. And yeah, we know we have x in both of them, but it's going to disappear. So let's go for it. So initially, we want r sin x plus alpha, but from the formula sheet, it's only sin x plus alpha. So we're going to go for the expansion. So which one is sin x plus alpha? It's that one there. So that's what we're going to go for. So when we expand that, that's what you get. You're looking at your formula sheet, that's fine. But in relation to the question, we've actually got something in front of the sin x plus alpha in the top line after the IE part. So that's why we have this. It doesn't matter about the letter R. I'm using that for the resultant amplitude. Sometimes you use K, sometimes you use the capital letter A. It does not matter one little bit. It's only a label. So here should be your next line here. So I've just expanded this. So what I'm going to do now is I'm going to equate coefficients. So this part here's got a sin x, this part here's got a sin x. So I'm going to get rid of the sin x and sin x from both. I'm going to have 4 is equal to the rest, r cos alpha. Okay, this has got a cos x, this has got a cos x. not interested in x. So what I'm left is 3 equals r sine alpha. So that's what I'm doing here. So emphasizing it here, 3 cos x equals that. So that's why I have r sine alpha equals 3. R sine alpha equals 3. That's where I'm getting that from. And also 4. I'm getting sine x is 4, r cos alpha. Right. That's where I get that from. I've got a pair of equations here. R sine alpha equals 3. R cos alpha equals 4. So what I'm doing here, I've got two equations. What I'm going to do is carry out a quadrant check. Usually, if you're sine and cos of an angle, there's usually fractions here. R would usually go over and divide. I'm just going to leave it here. All I'm interested in is the number positive or negative. So where is sign positive? You've done the quadrant check before. Where is sign positive in all and sine? You've done that before. Let's go downstairs. Where is cos alpha equal to positive 4 in all and cosine? So you've got that there. So what you should have on your page is 3 ticks, okay? And what you're interested in is which quadrant do you have the 2 ticks? It just so appears it's that one there, the first quadrant. That's fine. Okay. So since we're dealing in degrees here, it appears that alpha is between 0 and 90. Okay, so I'm going to label these equations 1 and 2. And I want to pin down alpha. So I'm going to divide 1 by 2. Equation 1 by 2, and it'll cancel out the r values. Okay, so I want you to notice here, that's what I've done. I've just brought them together. The r values are going to cancel out top and bottom. I'm going to have sine alpha over cos alpha equals 3 over 4. And sine alpha over cos alpha, a trig identity, is tan alpha equals 3 over 4. Right, so to isolate tan, the opposite of tan is inverse tan, not fake tan. So inverse tan of 3 over 4 in degrees. And it doesn't matter. Number of decimal points I've worked to. I probably just went to 1 or 2. I'm not sure myself. So here we go. 36.9. It's maybe 36.869 or something like that. I don't know. So I went for that. We don't get upset for that. Yeah, I'm going to go for that. Okay. So that's us pinned down to alpha. Right. In order to get the resultant amplitude, it's just a case of Pythagoras. And I might explain. I've tried to explain it later on why it is. So these are the numbers, the coefficients of the sin x and cos x. We're just going to square them, add them, square root them. So there we go. 3 squared, 9, 4 squared, 16, add them together, 25. Square root it. And we're doing with a positive value here. So square root of 25 is going to be positive 5. So that's our resultant amplitude, whether we call it R, K, capital A, doesn't matter. So, in terms of this little problem here, R is 5 and alpha, sometimes called the phase angle. People call it different things, doesn't matter. It's 36.9 degrees. So, overall, what we had here, when we're adding the two initial sines and cosines and sines together, and we stipulated, or I stipulated the format we wanted, sine x plus or minus alpha, it's plus alpha. So we've got r, we've got alpha, just pop them in place of r and alpha. And that's us. All done. Just remember, as usual, you can always backtrack and see what's going on. Right, okay. Let's go to the second one. 2 cos x plus 7 sin x. I'm going to express this. This time it's cos x minus alpha. That's important. This is important. What they're telling you to express it as. Sines and cosines are really the same. Okay, they're really the same. So let's go for it. Cos x minus alpha. Forget about r. We're going to the formula sheet. Cos x minus cos and minus. That's what we're going for. So it's that one there. Yeah, we know we're going to have r in front of it eventually. So there you go. That's all we've done. In the expansion from there, we'll just put r in front of it because we've got r. Okay. Right. Okay. So this is the page probably 4 pages back. We're now equating coefficients here. So this stuff is equal to that stuff. So that means a 2, we're getting rid of the cosec from both, is equal to r cos alpha. And with this stuff, we're getting rid of sin x. I mean 7 is equal to r sin alpha. That's what it means by equate the coefficients. That's how we've got that there. Okay. Put that there. And it's best to have the sin alpha at the top and cos alpha at the bottom, because we're going to do the sin alpha of cos alpha equals tan alpha. But initially, we need to do a quadrant check, just in case these pair might be negative, but it'll not, so this will be fine. Sin alpha is 7, it's positive, all in sine, A and S. Okay, let's move downstairs. Cos alpha is 2, 2 is positive, all in cosine. And when I bring it back, we've got our 2 ticks here and here. So that means we have the first quadrant, 0 to 90. That's fine. Let's deal with these two. Sine over cosine. We know we're going to get rid of the r value. Okay, deal with that. Deal with that. Sine over cosine is tangent. Tangent equals 7 over 2. If you want to write it as 3 over 3.5, that's fine. I'm not going to. But let's isolate alpha. Opposite of tan is inverse tan. Calculator might say whatever. 74.1. Whatever it says. That's fine. That'll do us. Okay, let's go for r. A squared plus b squared is the number in front of the sine and cosine parts. 2 squared plus 7 squared. 4 and 49 is 53. So we're going to square root of 53. I think I'm going to leave it as that. I'm not going to decimalize it there. I'm going to leave it like that there. So we've got r and alpha. I'm saying don't decimalize. You can do what you want. You can do what you want. So what we're doing here, so this is what the proposal was. Add D2, put them in that format. We found R and alpha. Put them. So the only thing you're doing here is putting R and alpha into this format. Don't change that minus, and you might want to call it a negative, whatever. Don't change it. That's what you want to do there. If you want to make square root of 53 in a decimal, go ahead. That's fine. Okay. Depends on the class group I'm dealing with. Have we dealt with trig identities? Maybe yes, maybe no. But some people do think about things. Ah, why is it telling us that you just get R from Pythagoras? Well, if you have dealt with identities, trig identities, then this might explain it a little bit. And if you don't quite get it at first glance, then maybe 2 3, 4, 5, 1, 6 months down the line, you might get it. So here we go. So we always ended up at this stage here. R sin alpha and R cos alpha is A and B. So what I'm doing here, I'm allowed to, what I do to one side, I'm allowed to do to the other. Okay? So I'm squaring both. I'm allowed to do that. Well, technically, I'm not really allowed, especially if something's negative on the other side. But we can get away with it here. So what I'm going to do is now going to combine these. Okay? And so, say the brackets here. If I'm squaring things on the left-hand side, R gets squared, sin alpha and cos alpha both get squares, and usually we put the squares between the trig part and the argument angle, if you want to call it that. So that's what we've done there. Okay. What's going to happen next? I'm going to add. I'm going to add both the equations here. Add them together. It can take out a common factor of r squared. Okay. Sin squared alpha and cos squared alpha. And once we're used to our trig identities, sin squared alpha and cos squared alpha. What's that going to be? It's actually equal to 1. Okay, that's why I can read here that r squared alpha is equal to a squared plus b squared. That's where I get that from. Okay, right, let's go back. That's why we can now just go straight to r equals the square root of a squared plus b squared. Right, okay. Let's go for another one. Express 20 cos x minus 21 sin x in the form r sin x plus alpha. Okay, so because it's r sin x plus alpha, we need to look at the formula sheet. What one and whatever, sine and plus. So it's sine and plus. Sine and plus, that's the top one there. That's the one that we're looking for. Okay. So here we go. We've expanded it. We've brought in the r values. Okay. For equating coefficients, that is equal to that. That is equal to that. We're getting rid of the cos x from here, the cos x from there, sin x from there, sin x from there. Watch, beware of that negative. Okay. That's equal to that. That's equal to that. Beware of that negative there. So that's what we're doing now. Get rid of the sine and the cosine. Okay. We're going to have sine over cosine here with the quadrant check for sine and cosine. Where's sine positive? You know it's all in sine. Move downstairs. Where's cosine negative? We know cosine is positive and all in cosine, so it will be negative in sine and tan s and t. So where's the two ticks? This quadrant here. Okay. So between 90 and 180, if we're dealing in degrees here, which we are. Right. Okay. So because of the quadrant check formulas, usually alpha initially in your calculator, what we're calling A is 0 to 90. So alpha is the second quadrant, so we need to get a calculator answer first. So if we're going through this process, get rid of r, sin alpha over cos alpha, tan alpha, negative 20 over 21. Just get rid of the negative here. Just get rid of it. Other systems work. Other systems do work, so don't get upset. So I popped it in my calculator, got about 43 and a bit, 43.6 I'm getting here. What I'm going to do here, I get my true alpha as 180, take away 43.6, I get 136.4. That will do me. Then I'm going to go for my R value, 20 squared plus negative 21 squared. I bracketed that there to ensure when I square a negative, I got a positive. So negative 21 also is positive for 1. 841 in total, square root that, you get a nice number, and we're fine. So, in summary, so a cos, take a sine, in the format they want, we've got R and alpha, let's just plug them in. That's what we're doing here. We're not changing any signs here, just plug them in. So, I think I'm there. So, I know that was quite a swift resume of what's going on here. So, I'm going to bring that. So hopefully everybody's fine. This is a part where I'm wondering if I have actually recorded it. So looks like I want to call minutes here. Right, okay, Tommy boy. I think I've recorded it. So, see you whenever, folks. Bye.